Hey guys, so as you can hear, I'm still not well. So what I thought I'd do is set you this worksheet on free body diagrams, but I've set it up in such a way that I'm just making this video so I can scribble and talk you through how to draw these guys. So let's get going. So this is, I think it's the very first question of the worksheet, and your task is to work out what the overall force is. So this F frict is the force of friction. F grav is the force from gravity. F ap is the force that is applied. So this is the force that you are pushing this box with. And then F norm is the normal force. So the normal force is that Newton's third reaction force. And in this case, my normal force is reacting to the force of gravity. So an example where I could have drawn this, sorry, excuse me. An example where I could have this actual situation is if I've got a table and I've got a book on the table. You can see that despite the fact that I should probably move my book over and change its colour so you can see it a bit more easily. So I've got my book on a table. Despite the fact that the arrow is on this side of the box, my force is being applied in the rightward direction. So you are pushing on this box from the left and pushing it right. Now, when you look at the size of this friction force, it's the same as the force that you're applying. So you are pushing that book, but not hard enough to overcome the force of gravity. It's then got the force of gravity pushing down on it and the normal force that is holding it to the surface of the table. So that's a situation where you might see this force diagram. So let's go through and work out. I'm just going to delete some of these scribbles so we can see a bit more clearly. So what I've got here is I've got 5 newtons going left and 5 newtons going right. So left to right, I have 0 newtons. And then upwards from the normal, I have 3 newtons. And downwards from gravity, so up, down, those two forces cancel. So I have 0 newtons down. So overall, this object, because we don't know what it is, we just know that it's an object, this object has 0 newtons acting on it in any direction. We call that an object at equilibrium. So what that means is that object, think about Newton's first law. An object in motion remains in motion, an object at rest remains at rest unless acted upon by a force. So this object is at equilibrium, which means that it is either not moving, not changing. It's not changing its motion. So it could be traveling at a constant, it could be traveling at a constant velocity, or it could be traveling at a velocity of 0, which when you think about it is traveling at a constant velocity. So overall, when you add up your arrows, it adds to 0 newtons, which is how you know that this object is at equilibrium, so not changing its motion. Okay, let's move on to the next example, which is the next which is the next type of question. So you are told that overall this has an F net of 0. So this 50 newtons right has to be balanced out by 50 newtons left. And this 200 newtons down has to be matched by 200 newtons up. That's the only way that I can get to that F net of 0. So the net is the force when all of the arrows are added up. Okay, so this one's pretty simple. It's just that basic maths to get your forces to add up to that overall number that's at the bottom of that diagram. Okay, I think our next two questions are the worded questions. Look, a book is at rest on a tabletop. A free body diagram. Now, free body diagrams are not meant to be accurate representations of what the objects look like. They're meant to be just a box in space or a sphere in space where you've got your force of gravity pulling down on it. So remember, make sure you label your arrow with F grav, and then you've got to try and draw the same length of arrow going in the opposite directions, because we're told our book is at rest, which means that F net has to be equal to 0. So if I've got F grav pulling down, I have F norm sticking up. And if you had a ruler, you'd be doing it with a ruler, but I'm just eyeballing it. This F norm looks a little bit short now that I look at it again. You're trying to make those two arrows the same size, the same length. We don't in physics show big forces by using fat arrows. We use them by using a long arrow versus a short arrow. And it's completely fine to exaggerate this in those situations so it's super clear which force is larger. Sorry, excuse me. Okay, let's go to, I think the second one I picked did have unbalanced forces in it, which is why I chose it. So let's do this last one. So I have a sled. I have a force being applied to the right, and it is accelerating right. So my F net, oh, not met, net, be good if I could spell, my F net is going to be not equal to 0. It's going to be towards the right. So the fact that it says loosely packed, I know that it's probably not obvious to Australians, but what it's saying is the force of friction is going to be an issue. So I'm applying a force to the right, so that is an F app because it's the force that I'm applying, and I then have in the opposite direction the force of friction. Okay, so that's more or less the end. Thank you for listening to this video. Sorry that my voice is so rough, and hopefully I will be back at Hopefully I will be back at school soon and we'll be able to go through everything. Once you've done this worksheet, you can, and I think I put this on Compass, you can either finish off the activity that you started towards the end of yesterday's class, and I've also put a link into a simulation for some more complex free body diagrams, and you can actually click and change the length of the arrows in that simulation to do these unbalanced forces. Thank you so much. Have a lovely rest of your day, and I will hopefully see you soon.